So here we're given a bunch of different ground state electron configurations, and we are to determine whether or not they are correct. So let's start with chromium. So chromium might jog your memory, and you might remember that this is one of the exceptions that we have. So it doesn't feel exactly to what you would think. So we locate where chromium is on the periodic table. It is in the fourth period. So we go one period up and all the way to the right. We should start off our configuration with argon. So yes, we have that here. And we have four s2 electrons, and we take 4 electrons in order to get to chromium in the d block electrons. And how you start naming your d block electrons is that this actually starts with 3, and then you go 4, 5, 6, etc. So because you should normally expect a 3d4 and a s2, chromium is one of the weird exceptions, so you do get 4s1 and 3d5. So that is actually the correct configuration. So let's look at copper plus. Copper plus is located here, same period, so you start with the same noble gas shorthand, and you have 4s2 electrons and 1, 2, 3, 4, 5, 6, 7, 8, 9 3d electrons in order to get to copper. But again, it's one of those weird cases and weird exceptions. So your neutral species should have 4s1 and 3d10. So because it's copper plus, you lose one electron from the highest energy orbital, which is the s. So because you lost one electron here, this should write 0. So yes, this is the correct configuration. So let's look at iron. So we look at iron, again, same period, and it's all the way over here. So for S2, 1, 2, 3, 4, 5, 6 in order to get here. But however, again, we named D block electrons starting with 3, and this is 4, this is 5. So this should actually say 3d6, not 4d6. So this is not correct. So finally, let's move on to titanium 2+, same period. So we start titanium is right here, so we start here, so it's 4s2 and 3d2 in order to get to titanium, but because it's 2+, so it's lost 2 electrons, again losing it from the highest energy orbital, which is the s. So yes, this is the correct electron configuration. Moving on to cobalt-3, if we look here, cobalt-3 is again in the same period, so moving all the way over, you should get 1, 2, 3, 4, 5, 6, 7, 3d7 for the neutral species. But this is cobalt-3+, right? So you have to lose 3 electrons. And again, you have to lose from the s orbitals first and then the d orbitals. But in this case, it's showing the opposite. So this s orbital should have lost 2 electrons, and you should have lost 1 electron from the d orbital in order for this to be the correct configuration. So this is not correct. Finally, we want to move on to cadmium, and cadmium is here on the 5th period. So if you go one up and all the way to the right, chromium is where you should start your, krypton is where you should start your electron configuration. And let's start filling in electrons starting from left to right in order to reach cadmium. So we have 5s2, and we have 4d10 in order to reach cadmium. However, the configuration here says we actually have 3f14 electrons, but no, that's not the case, but because we only start counting up electrons when we start in period 6. So this is also the incorrect electron configuration.